This is Algebra 2, Lesson 53, page 229. The first part of this lesson is metric conversion. So you've learned some conversions. Now, here are three more that you must know. 100, this is this lesson, 100 centimeters is 1 meter. 1,000 meters is 1 kilometer. 2.54 centimeters is equal to what? 1 inch. In your higher level maths and sciences, you are going to be in the metric system. It is rare in your college sciences that you're going to use English measurements. But here is how we go from the English units to the metric units. Okay? All right. So that's the first part of this lesson. Let's work practice problem 53.1. It says convert 7,560 centimeters. We want to go from centimeters to kilometers. Can we go straight from centimeters to kilometers? No. Well, we could, but we're not going to. All right, centimeters, we go from centimeters to where? To meters, right? 1 and 100, right? Because this is really like it's over 1. So remember, crisscross applesauce is how we can eliminate the measurements. So now we've eliminated centimeters. Now I want meters in the denominator, kilometers in the numerator, 1 over 1,000. And you, again, meters is eliminated. We don't have to multiply these out. You can, but you can write your answer this way. Make sense? No need to multiply them out. Your textbook actually multiplied them out for this problem, but I'm saying you don't have to. All right, look at example 53.2 on the top of the next page. Probably in that expression, in that equation, in your college level sciences, you would probably have to write that in scientific form because you would have to think of significant digits, right? Yes, you would have to. I'm sure. However, I will tell you it's been across the board for all my kids, because they've all taken chemistry in college, that significant digits in college were so much easier than it was in high school. I don't know why they say that, but that is what they do. All three of my boys. All right, look at example 2 on the top of page 230. Convert 15,740,000. Look, this is square centimeters. So what does that tell you already? I'm going to have to 2 unit multipliers. And we're going to kilometers. All right, so what's my first one I'm going to square? Well, that was pretty bad squaring. Right, how many meters in a centimeter? How many centimeters in a meter? 100. And then we multiply, we want meters in the denominator, kilometers, we're going to square it. And so we have 1 kilometer is 1,000 meters. So again, you can write this 15,740 million over 100 squared times 1,000 squared. It doesn't matter if the square is inside or outside the parentheses, does it? Because it's both positive values. Kilometers squared. All right, makes sense? not rocket science, is it? Well, actually it is. Yes.
Leave it like that, or do you want
Yes, you can leave it like this. I say this is rocket science because this is physics, and physics, rocket science is part of physics. It is. We're about to learn some more physics. This lesson and the next one are both physics. Okay. Well, and there's some chemistry, but both of these lessons are science lessons, are the math part of the science. All right. Now we're going to go between English and the metric. This is where we're going to use that 2.54 centimeters and an inch to convert it. All right. Look at example 3. Use unit multipliers to convert 32 yards, and we want to go to meters. All right. So I start out with 32 yards. What's my first multiplier? 3 feet in 1 yard. Then, what's my next one? I need feet in the denominator. Yep. Inches. 12 inches in 1 foot. Now I'm going to centimeters. Inches in the denominator, centimeters. What's my unit multiplier?
2.54.
Centimeters and an inch. Then I'm going from centimeters to meters. 1 meter is 100 centimeters. And again, you don't have to, you just put the numerators in the numerator, so it'll be 32 times 3 times 12 times 2.54. You don't have to list the ones. Over 100, and we went to meters. You may leave your answer in this form. Again, if you were in a science class, you would probably have to contemplate your significant digits and potentially have to write it in scientific form to make sure you had the right number of significant digits. Are y'all doing that in chemistry? Have y'all done that in chemistry? Like having to convert to scientific form because of significant digits? All right, that's good. So let's keep that connection. All right, look at example 4. Now we're going to convert 0.042 kilometers squared. Wow, we're going to go to miles squared. This is going to be a lot of miles squared. I wrote it down there. Okay, so again, our initial term is squared. That doesn't mean I multiply this twice. It's already squared. So every one of my multipliers is going to be squared. All right, so where do I go from kilometers to meters? What's my multiplier? 1,000 meters in a kilometer. All right, now I'm going from meters to centimeters. And what is that? 100 centimeters in a meter. Now where I'm going? Where am I going? Where am I going? Yes, inches. So inches over centimeters, and it is 2.54 centimeters in an inch. And I have to square that one. Now where am I going? To feet. Can I go to yards? Just wondering. No, we want to go to feet. Why do we want to go to feet? Feet to miles. That's right. Okay, so 1 foot is 12 inches. That's squared. Now we're going to go to miles. 1 mile is
5,280
feet. All right, so let's look at this. It's 0.042 times 1,000 squared times 100 squared. Only other values in the numerator is 1 over 2.54 squared, 12 squared, 5280 squared, and you can leave your answer in this format. Okay, that's probably a breath of fresh air, right? To start the lessons out this way, probably. Okay, the second part of this lesson is not hard either. We have done comparisons of compounds. Like we've had, let's just say H2O. And so the weight of one, hydrogen is 1, oxygen is oxygen 16 or 32? 16. So my initial brain was right. My initial thought was right. What's 32 though? I can't remember. And suppose that the weight in our other mixture of water, the hydrogen was 8. What was the total weight? Remember these? Kind of remember these? All right, the difference with what we're learning today is it is going to be a percent. So instead of asking you what is the weight of the compound or one of the elements, it's going to ask you what percent is one of the elements of the total. All right? Does that make sense? Maybe. Okay, let's just do the example. What percent by weight of Na2, S2, O2 is the sodium, Na? So to find the weight by percent, we're going to do the Na over the total. But to get it in percent, that would give me a decimal. To get it into percent, we're going to multiply it by 100. And that puts it in percent. Because remember, to go to decimal, from decimal to percent, we move the decimal place to the left to get it into percent. And they will always give you the weights. All right, so Na is 23. I'm just going to write the little weights above it. It gives it earlier in the problem. Sodium is 32. That's what's 32. And oxygen is 16. All right, so what is the weight of 2 sodiums?
46.
46. And of the sulfur? 64. And of the oxygen?
32.
So what is the total? That's 10 and 2 more is 12. Carry your 1. What do I have here? 14. So if I want the sodium weight, it's going to be 46 over the total times 100. And using your calculator, what is that? We're going to figure out the percent of all of these because it should add up to 100. What is the percent weight of the sodium? Who has that? Yes, Dress.
Oh, I don't have it, but I was going to ask, could you do 46 or 142 is equal to x over 100? Would that work? Like 142.
Then I would be dividing by 100, so I'd be moving the decimal place in the wrong direction. Well, yes, but that doesn't express it in terms of percent.
What does it express it as?
Still decimal. All right, so what is this, guys? Who has it? 32.4%. All right, figure out the weight of the sodium and the weight of the oxygen as a percent of the total. So y'all calculate that and let's give me those answers. Give me those responses. And actually it was 03 in your book, but I did 02. So there we go. It's probably not a good compound. There's probably not a compound that looks like this, but we're going to keep working it this way. All right, what's this? Who has the sodium weight as a percent? Yes.
It's 45.1.
45.1. Who has the oxygen? Yes.
22.5.
22.5. All right, should they add up to 100? Yes, they should add up to 100. Looks like they do. That's 0, that's 10.
Shouldn't they not because we didn't do 3 oxygen?
Well, they should because
they
this
should.
is, yeah, we're 1% off. Oh, did I not? I didn't carry my 1. You're exactly right. It's 100. It does add up to 100. So your total should add up to 100. All right. Any questions from this lesson? It's going from English to metric and knowing some metric conversions, and now we're looking at the percentage of the weight of one compound in a mixture.